analysis space. So we collected a total of more than 700 publications from the Web of Science over a year, almost 20 years time frame from 2005 to 2022. We focus on the peer-reviewed paper explicitly related to Chinese sentiment analysis. So we included studies covering various domains like the microblogs, news, e-commerce, finance, and healthcare. So the methodology we use a couple of analytics frameworks. Here one is a keyword concurrence analysis. We try to extract the most frequently used in the keywords in all these 600 publications and try to identify the communities through the community detection algorithms, and also did a temporal trend analysis to see how over the years what are the changes in the terms of the keywords and the community along the years. So this is shows the number of articles we collected over the years. So you can see that at the very beginning we have a very small number of the research from the 2005, and by the time of 2022 we have 124 articles included in our research. So the kind of very steady trend of going upward trend of the Chinese sentiment analysis in the research. So we did the subject analysis. By the right-hand side, we show all the major keywords and the frequency. The most frequent keywords are microblog, but this is probably our basically the Twitter counterpart in China, right? So they started earlier, and then this is very popular in China. And also, I think the number 2 is deep learning. I think that shows the methodology of deep learning actually gaining the attraction of the years, and the social media and text mining followed by the, I think that's very natural because we are doing the sentiment analysis, right? So we also try to find out the machine learning based approach and deep learning based method, and we find some interesting trends. I think that trends will be more obvious when we see more diagrams of more results through our diagrams later. Let me show some. Here we show the networks. This is the network shows how frequently used to keyword related to Chinese sentiment analysis are interconnected. So it's quite a bigger graph. I think the biggest bubble is microblog, right? So you can see the methodology here. You can see the BERT, STM, word embedding, SVM, Chinese text, machine learning, right? So the social media here, we see the Weibo text mining and opinion mining. I think that at C4 we also see the COVID-19. I think that's also a very big event in China, right? So yeah, that's a lot of keywords are interconnected. So this shows this figure shows the evolution of the keywords over the years. So we grouped all the keywords in different communities, like C1 to C6, and see all the community categories within the years. We can see the growth, the trends. I think some obvious trends, interesting things. Maybe it's the C4. You see the very beginning is very small. I think then since 2009 it grows very significantly, and 2022 it's probably outweigh the other what yeah. But I couldn't find the link there. Well, what is the C4, right? So, but that's another result shows here. This is the high frequency keyword for community C1. We break down that to see the C1, C4, and C5, and it shows the trend over the 18 years. So the microblogs, it has a very significant impact from you can see the trends or details. Let's say COVID-19 only happened in 2022, 2020, and or maybe going down maybe after the 2022. Probably nobody really, really worry about that too much yet. So this is another diagram showing the community C2, C3, and C6. As we can see, the different different methodologies used in the literatures. So you see after very obvious trend is that after 2015, then the deep learnings will become more and more common in the literature, and everyone probably over the years, we can see all these the traditional machine learning algorithms are still being used. The BERT is the invent of the transformer large language models starting from maybe 2018 here. The BERT, when it is invented, it will be utilized in all the natural language processing, including in Chinese also. The researchers adapt them for Chinese sentiment analysis. So the latest trend, actually, I think after in the last couple of years, of course, is the large language models. In China, also, the big companies like Baidu, they also have their own large language model called Ernie or Wenxin Yan. Their large language models are also being used for sentiment analysis. Then we also have some special large language foundation models like Wudao. And we also have a kind of a fine-tuned version of BERT called MAT-BERT. And other GPT-based models like ChatGPT. I'm very proud of that. Also, the ChatGPT is built by Tsinghua University, where I got my bachelor's degree. So they're very popular in the open source large language model space. So there's still some challenges in the current Chinese pre-trained model. So still they need to handle the dialect of regional variations. So I believe most of the traditional Mandarin is kind of a normal, normalized Chinese language, but a lot of people actually have different dialects, right? So that part probably the pre-trained model still need to adapt to, and so they also have some challenges in the sentiment analysis. Many Chinese phrases rely on implicit meanings and cultural context, so which makes sentiment prediction more complex. That's also large language always have the kind of bias, right? So we will need to, that's always a continuous effort to reduce bias in the sentiment models, ensure the fairness of sentiment prediction. So that's the latest trend and utilizing large language models for Chinese sentiment analysis. Let me summarize to kind of conclude. So the key takeaway here is that Chinese sentiment analysis is a rapid evolving field, and it's the research has shifted from the initial rule-based to and the lexical method to deep learning transformer models, and nowadays probably is a combination of transformer plus large language model. Large language is also transformer-based model, right? So the emerging techniques include the multimodal sentiment analysis, domain-adapted models, cross-lingual learning, and integration of large language models. Data sets and the evaluation continue to expand, and which I prepared a couple of slides, but I think we don't have enough time to cover. There's some of in the paper also mentioned a kind of a specific Chinese sentiment and data sets and the evaluation methodology as well. Chinese sentiment analysis has a very strong practical application, especially in the social media monitoring for e-commerce, financial forecasting, and healthcare. So that's why as even in my work in my mastercard, I'm also very interested to leverage the latest sentiment analysis methodology to see how that could help us to gain our brand names, right? So that's one direction we are also working on. And the sentiment analysis will definitely play a crucial role in policy analysis and crisis management, public sentiment tracking. The future direction could be something like development of more advanced Chinese pre-trained language models. Recently, I have been experimenting with quite good open source models from China. I think I worked on the Queen 2.5, and Intern LM, and they're all from China, right? So the most recently is the DeepSeek R1. I recently got a written paper on using DeepSeek R1 for sentiment analysis as well. So yeah, so I think that's also another direction could be addressing the linguistic complexity of the Chinese unique features we need to address, and we also need to address the regional dialects and cultural nuances. Yeah. So another dimension is another direction could be the multimodal analysis, combine the picture, video, and text together to see how can we get better sentiment analysis result. Yeah. So yeah. So I think few shot learning is quite normal if you are using large language model. So my recent paper using DeepSeek R1 actually used a few shot learning to direct the model to really give the classification of sentiments for the data sets. Yeah. So yeah, that's all. Hi. Thank you. Any questions?
So I was wondering, for the review, we were focusing mostly on like syntactic approaches to, for example, the difference between how to parse English or Chinese characters. I wonder if any of those papers also look at like cultural nuances or common sense differences between Chinese common, like Western and Asian common sense, something like that.
That's a good question. I would ask the professor to answer that because she is the expert in that. Yeah, please.
Okay,
Yeah.
thanks.
Thank you.
Next is Sha Shulang. You the projector went off. You want to use this? This or this? Okay, here you also have the QR code for those who want to pass on our questions later. And next talk is by Dr. Shulang Zhang about multilingual emotion recognition.
Hi. So today I'll be sharing our paper that is published last year at IJCNN. It's titled Multilingual Emotion Recognition, Discovering the Variations of Lexical Semantics Between Languages. So just some backgrounds. Research in linguistics and psychology has shown that the meanings and experiences of emotions vary across cultures and languages. However, multilingual large language models, also known as XLM, are not very good at representing these cultural variations. This is because they are either they are trained by implicit alignment or explicit alignment. It actually anchors the word meaning or emotions to English. So this makes SLMs Anglocentric, and it erases some of the cultural nuances that are inherent in languages. The research has shown that although there are some universal patterns, concepts are actually perceived very differently across cultures. Especially emotions are one of the most diversely perceived concept categories across languages. For example, shame in English is much more negative, much perceived as much more negative than in Japanese. So in this paper, we define this kind of different interpretation of semantic concepts across cultures and languages as semantic variations. So the core idea of our paper is to rectify the embedding space of XLM by injecting these semantic variations as features. So how we do this is by mapping the English embedding space to the target embedding space by using concrete concepts. So this is based on the assumption that concrete concepts should be more similar in the semantic space of different languages compared to abstract concepts. Yeah. So the contribution of our paper is, first we propose a task-agnostic method to inject important linguistic intuitions, that is semantic variations. And then we evaluate the proposed method in emotion classification across 2 XLMs and 3 datasets in Spanish, Japanese, and Chinese. So the methodology is as illustrated in this graph. So the red plane is the semantic space of English. The blue plane is the semantic space of the target language. And the X on both planes are the concrete concepts. And the circle and the triangles are the abstract concepts. So the idea is that we train a rotation matrix R that maps the red plane to the blue plane using the concrete concepts as anchors. And then after we map them, the concept, so usually these are abstract concepts that are quite far away from the rotated embedding that are quite far away from the embedding in the target language. So as you can see the triangle and the circle here, that signifies that these are the concepts that are perceived differently across different languages. So yeah, like I said, the first step is we find some concrete word pairs to use as anchors. We find this by utilizing some existing concreteness dictionary to construct such word pairs in English and in the target language. And because the main idea is to inject the cultural variations into the XLM, so we use the XLM's embedding space as the semantic space of English, and we use a monolingual PLM in the target language as the blue plane. Yeah, so we then just train the rotation matrix using the using the MSE loss to minimize the Euclidean distance between the concrete word pairs from both word planes. So after we acquire the rotation matrix, we can then apply it in our emotion classification models. So as you can see here, we have target language input, and we use a word-to-word machine translation system to translate it to English. And then we put it into the monolingual PLM and the XLM. So we can then compute the semantic difference using the trained rotation matrix. And after we acquire this, we can then, through a gating mechanism, to add it back into a XLM-based model's embedding space. And then we can just proceed to classify the emotion as you usually do with a PLM-based model. So due to the space limit, we only show part of the result here. But yeah, we experiment on two backbone models on 3 languages. So as you can see from the results, we improve upon both of the backbone model on emotion classification. Yeah. And we didn't show it here, but also for most of the emotion categories, we also achieve some better performance. And we also conduct human evaluation to verify whether our method can reliably select words with high semantic variations between languages. So we do this by first construct word pair lexicons for each target language and each XLM. So that will be 6 lexicon in total. And then for each lexicon, we rank all the word pairs based on the semantic variation score. And we choose the top 50% as test pairs because we're trying to measure the abstract concepts. Yeah, so we form a test instance by selecting, randomly selecting two word pairs from a lexicon, and then we ask the evaluator to identify which one they think is more semantically different. And then if the higher ranking one is identified as the more semantically different one, then this is a correct test instance. If not, it is wrong. So yeah, by using this methods, we can see that the accuracy of our model selecting the the concepts with higher semantic variations to be more, to have a higher semantic variation score. Yeah, so to conclude, we propose a task agnostic approach that incorporates semantic variations between languages into XLM embedding space. And then we use some experiment and human evaluation to prove our method's effectiveness. So thank you. Maybe, for example, you get like, let me think. Maybe you get like liberalism and 自由主义. This is a word pair. And then another word pair might be 沮丧 and upset. So you can, so the evaluators, they are allowed to like use dictionaries, or they're given some time to think about which one they think is more semantically different or perceived differently across different languages. So there, a test instance is formed by 2 word pairs. So if you think 沮丧 and upset is more perceived more differently in English and Chinese than 自由主义 and liberalism, then yeah, that is how you, yeah, yeah. Yeah, that is the idea, but we didn't specifically phrase it like that in the instruction. But yeah, that is the idea. Yeah, because they are encouraged to use like dictionaries and stuff, so they might be able to identify that. Yeah. Yes. 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 Yeah, so the idea of this, or the motivation of this paper is that the XLM are grounded in English. So we mainly compare other languages to English because this is how the XLMs are lacking these days. So for maybe expanding to multiple languages, as XLM usually does, we think that maybe we can just compute the semantic variations as features on the go. So the XLM, they are still, they are kept as it is. And then when you're inputting different languages, and then in the first step, you just compute a semantic difference on the fly. And then you just insert it into the embedding. So yeah, so since this is not directly changing the base model, so I think it will also work in different languages. Yeah.
Okay, thanks again.
Thank you.
Next, I think we have Prof. Gianmarco. Yes, Prof. Gianmarco Mercado came all the way from NUS to give us this talk, and today he's very busy because he has to give another talk later. Are you want to use your laptop?
Yeah, today. No, probably we need to switch it on again. Good. Can you hear me well? Also back? Good. All right. Well, thank you, Eric, for the kind invitation here. So it's an unusual audience for me, so I'm not really used to talk to computer science audience and natural language processing especially. Well, this is more on the application side. So what we try to do in this work is some sentiment analysis on some financial business, but blending together some aspect of climate, okay? So usually when you talk about climate and finance, you think about ECG, right? So we have environmental, social, and governance aspects that are usually taken into account in order to understand sustainable investing. Now, in this particular work, we consider only the environmental part, and we ask a very simple question: what drives green stock pricing? So you have a bunch of green stocks. What is driving their price? What are the main factors doing that? So we used two works, one from Eric's group, this one that aggregated a lot of tweets about climate change sentiment, and this second one, which is from 1993 by Fama and French on the financial side, which is the standard three-factor Fama-French model. So we assembled these two pieces of work together to come up with this work, which is sentiment analysis on climate change for sustainable investing. Okay, so we assembled these two different aspects together. And really what we did is collect some data, asset prices and tweets, do a relatively simple sentiment analysis, construct some sentiment scores, and regress them against the Fama and French model. Okay? And I will explain them next. So very briefly, in fact. So the data collection that we did on the asset price aspect, well, we collected some green assets, including ETFs, okay, and single stocks. So So here an example of them, as well as brown or non-green assets. Okay? So we collected both of them, also in this case some ETFs, as well as single stocks. We then collected some data on climate change and the environment, if you want, in the ESG component of ESG investing. And we use, again, as I mentioned, this particular data set that was published in this paper in 2022. Here is an example of a couple of tweets where they provide also sentiment as well as the specific topic they are talking about within the context of climate change. We then perform a sentiment analysis with a pretty standard model. Now, if you ask me how this works, I have no idea. Probably you are much better than me, much more suited than me on how this works. In fact, my student there, Keen, who drove the work, is responsible for this architecture and these technical aspects of it. So we train again on that data set that was presented from Eric's group, and we compute a sentiment score, which is focused on the negative sentiment in particular. We provide the monthly frequency of these negatively labeled tweets corresponding to a certain topic, and we normalize these sentiments with respect to the actual factors that we have in the three-factor model, Fromm and French. Okay? So this is an example of a sentiment score across four different topics and the aggregated one. So you can see that these sentiments varies quite widely over time. And we regress that against the Fromm and French model, which is this relatively simple econometric model, okay? So for which we have unexplained excess returns by the model. Then we have three factors here and the error here. So this part is the excess return that you would have against, for example, the standard market benchmark that you might get. Okay? So the idea here, well, let me go to the next slide. The idea here is, well, let's add this sentiment score here as a fourth factor. Okay? And ideally, we want to drive this alpha down, because if we drive this alpha down, it means that we are actually explaining more excess returns related to certain green stocks that we have. And these are the results. So this is the new four-factor model. This is the comparable three-factor model. And if you look here, for example, this particular asset, we are in fact reducing this alpha score with respect to the traditional model. It is obviously not extremely consistent, so this is a relatively short study that we did. But I guess the main conclusions that we draw is that coefficient beta 4, which is associated with sentiment score about green investing, is positive for green assets and negative for non-green assets, which is something we would expect. Change in alpha decreases for green assets related to climate policy and mitigation, one specific topic. So it seems consistent with this specific topic here, and increases for brown basket stocks. So this perhaps is not actually explaining well brown basket stocks. So these are the main conclusions or main observations of this new four-factor model. And I should note that some of them are not statistically significant as well. Now, some final thoughts here. So we think that it is promising, this new model, yet there is this particular issue of statistical significance, which might be due to the fact that we have quite a bit of noise in constructing sentiment scores. And one other aspect that we should add possibly to this analysis is actually look at the changing sentiment scores rather than to the raw sentiment scores. This is something that might be promising and might improve both the statistical significance as well as the correlation in beta 4. And there are a few other aspects that we can explore to improve this particular model, which I think is quite promising. So we didn't investigate it further, but I think is a pretty low-hanging fruit that we should actually pursue further. Some other ongoing works actually on the same ESG aspects. So we have ESG Senticnet with Eric's group, as well as Keen, who is doing a PhD with me and Eric. And we also have a review coming up with Eric's group. And that's it. Well, thank you, Eric, for the invite, and thank you, guys.
Questions? So in this work, where and if do you take into account the possibility of greenwashing, like in that formula, that positive for green stocks?
No, we didn't take into account maybe a possibility to further expand this work, yeah.
Any idea on how to do that?
Yeah, so I think possibly the most low-hanging fruit for improving this work is, as we were discussing with some finance experts at NUS, is looking at the derivative of sentiments. So these changing sentiments rather than the raw sentiment score. And that should correlate better with the French model, for example. So that is one thing that we should look into as a first step, probably. Okay, thank you, thank you.
Thank you. Hello, everyone. I currently work as an assistant professor from the sociology division in the School of Social Sciences. And so I guess sociology or social science is probably another field to many of you. So basically, we study whatever is happening in a society. How societal influences, including how the society is structured, influence human behaviors, as well as how people make their individual choices to influence the society at large. So basically, I'm going to talk about, firstly, the application of sentiment analysis in some of the social studies within social sciences today. And I'm also going to talk about a project that I'm just starting with Prof. Eric and some of the difficulties or some of the progresses that we've made so far. With the availability of data from all the different platforms, for example, social media or other places, and with the techniques such as sentiment analysis and computational methods emerging, it's becoming a very promising or very hot field within social sciences. So for example, so many studies has been done using sentiment analysis to study social phenomena. So for example, this study finds that aggregated public opinion data may actually misrepresent the actual emotional responses of different social groups to COVID-19 news, or may actually misrepresent different responses or emotions from different periods of time, right? So the paradox actually arises due to, for example, shifting external conditions, the severity of COVID-19, or policy changes, or even media influences and things like that. So there's another study done to sort of, so it's more like a method paper, but in the case study they used over 29,000 tweets from January to May, analyzing the engagement patterns across different political ideologies. So, they said that, okay, social media interactions, they probably use some network analyses in addition to sentiment analysis also. So they said that all these interactions can actually help to predict political attitudes, so which may become super helpful when elections, for example, happen, right? So, these are just two examples of how sentiment analysis has been applied to other fields, for example, social sciences. But some of the common concerns within applying sentiment analysis to social science is actually, for example, data availability, especially with Twitter or X or other platforms making researchers paying tens and thousands of dollars to obtain data nowadays, as well as the representativeness, because we know those who actually speak on social media or media in general is a selected sample within the whole population. And also, some of the other concerns might be, some of the current tools may struggle with dealing sentiments, for example, sarcasm, right, irony, or dealing cultural variations, leading to misclassification of emotions. So I was happy to see Shilang's work actually was about that. And some of the Western-trained sentiment tools may actually misinterpret, for example, Chinese data or data from other areas. But today I'm actually going to talk about some other concerns that I found when I started my project in childbearing sentiments. So why I started this project on childbearing sentiments is because declining fertility is now a concern of the world, society, or of many different countries. So for example, people sort of worried about South Korea disappearing from the world 50 years later or something due to not enough baby being born in the society to replace its current level of population. And Japan, China, Singapore is no different from that. But this issue is not only pertaining to East Asian countries, but also many of the developed countries, they all kind of face these sort of issues. As you see, the pattern of overall fertility decline is obvious. So basically, Lancet had a report saying that by 2100, so that's not far from here. It's about 70 years later. 97 countries will have fertility rates below what is needed to sustain their population size. But so different countries were worried about that. They have been implementing policies trying to increase the fertility level, including Singapore, right? We do have a lot of policies about, for example, buying BTOs. People can get married and then they can buy BTOs and things like that to promote fertility. But and including China, who's opening the second child, and then followed by that the third child policy. But it doesn't seem to have much of an effectiveness in kind of promoting fertility. If people do not want to give birth to a child, they still do not want to give birth to a child, right? So the current project explores public sentiments toward childbearing on social media. So what people are saying about giving birth to a child or parenthood on social media platforms. So what kind of data do we have, right? So because it's a starting project, so what we have is a 1-month sample from Weibo, which is a commonly used Chinese social media. And we, sort of search for some keywords, and we applied some filters to the ads. And the result was about 38K raw posts as well as comments. And then we applied some engagement filters. For example, we only wanted, because that was a lot data from Weibo. So we applied some engagement filters to have, for example, posts with certain likes and comments. And we also applied some large language model filter so as to filter out the posts that are seen as irrelevant. So now a sample of data from a month of posts and comments from Weibo is about 2.5K relevant posts. But we're thinking of whether to loosen the engagement threshold just because of, just to think about, for example, representativeness and things like that. And from Reddit, we've also been exploring Reddit. But from Reddit, the issue is that we know that Reddit is probably used by many users from different countries. So, but it's difficult to find country-specific information from Reddit, where we are able to deal with cross-cultural comparisons and things like that. I mean, there are still ways to sort of solve it. For example, we can go to country-specific subreddits to sort of seek for data and things like that. But the issue is then it's not the optimal kind of choice that we wanted to make, right? To go to country-specific subreddits and things like that. So I would like to present some of the sample data that we have now. So the sad news is even after cleaning by some large language models, the overall relevance in the sample output that we get is still about 20 to 30%, which is not quite satisfying to say. So, actually today, what I'm presenting here is also where we wanted to welcome all the comments and suggestions about how to better deal with data cleaning part. So some of the comments that we have here is, for example, this comment on the left is seen as relevant. So basically it's talking about the experience of someone who posted. And she said that even though my body is changing, growing a baby is still such a beautiful thing that I don't feel like it's worth the sacrifice. So that's probably considered as some thing that, as pro childbearing, or they, are in favor of childbearing. But here, the comments on the right, so for example, we also got some irrelevant posts from the keywords that we searched. So for example, I got COVID at 9 weeks and spent a whole week with high fever. Baby is absolutely perfect. So it's actually talking about some medical experiences, but not really their, thoughts for parenthood, right? And also, if you plan on breastfeeding, so basically the second post is talking about suggestions for breastfeeding. And the third post is again talking about some experiences of depression and having poor support from family during raising a kid, right? Well, they all does something that is relevant to raising a kid. They're not exactly the kind of posts that we are looking for in terms of answering our research question. And I also have some relevant examples from Chinese social media. So, for example, the first post you can see as relevant because it basically talks about some attitudes towards parenthood. And then the second also, right? But the third, it's somewhat relevant, but it's kind of a neutral attitude because it's talking about, okay, these are the reasons, but the post itself does not really have an attitude towards childbearing. And the fourth, the sixth, the fifth, and then the sixth, the last three, we should probably treat them as irrelevant posts because they don't really talk about whatever they're thinking towards parenthood, right? So for example, for the last post, you're not really sure about what exactly is being talked about by saying the millennials, or I'm not sure if it's talking, but those who are born after 2000 is great, right? So you're not really sure what has been talking about in that post. So basically, an overview of what we have done to clean the data. So we applied rule-based approach to filter out the ads as well as posts that have low engagement. So the good thing about that approach is this, it's simple and it's very efficient, but it requires extensive domain knowledge. For example, what we think will be a word that appear in the ads and things like that. And we also tried embedding approach, but for filtering out posts that are irrelevant. So it's computationally efficient, but the results is still fairly noisy. And at the last, thanks to ChatGPT, DeepSeek, and all the large language models from being there, we tried this LLM approach to filter out the irrelevant posts. So that's good because we actually, for research questions as specific as all these social science questions, we actually need the models to have some reasoning capabilities to detect the relevant posts as well as posts that are not quite relevant but contain some sort of keywords. So it delivers higher quality of results, still not super high quality results, but it has very high computational and financial costs as well as the time that's required there. So yes, so basically that's the new kind of challenge that we have encountered while we start to move or to push this project forward. So first of all is pertaining to data availability. So for example, location information, we just cannot get it with, for example, if we have a account or have a official API, we're able to get it, right, from X or something like that. But the official APIs are super expensive. So this is an example of the pro license of an official API from X. And that's not considered actually to be enough. So if we wanted to get enough data, we'll need an entrepreneurship API from Twitter, which is something that we are probably not able to do. So this is probably one issue that we're facing now. And the other issue is that while we are still trying different methods to see if data cleaning can reach an acceptable level of efficiency, so there are challenges pertaining to that because now, even after trying the LLMs, the noise level is still pretty high. So I welcome all the suggestions or feedbacks about if there are other ways that you think might be relevant to improve the efficiency level in terms of data cleaning. And so the other thing is, again, related to, for example, if we're not able to have API, or if the current funding is sort of constrained to support having an API or GPU sort of resources, the data cleaning can take super long for the amount of data we have. So an estimate will probably be taking about several months to conduct one round of data cleaning using some large language models and having that run on a local computer. So that's probably about all of my presentation. And thank you for listening to this emerging project, and I welcome all questions and suggestions, especially about how we can push this project forward. Thank you so much. I think that has something to do with the research question, right? If you are just looking into the sentiment of parenthood or childbearing, then that's considered as a relevant post. But if you wanted to explore the reason behind why or why not they are considering parenthood, then you'll probably need some reasons in the post that you're looking for. But so far as we are exploring the sentiment, it will still be considered as a relevant post. Yeah. 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 That's a very good question. I'm not fully able to explain that because yeah. Mm-hmm. Okay. Sorry, I don't have that. Yeah. Yes, I think these are very good suggestions. And actually, so I'm a sociologist. So this everything in computer science, the best I can explain is what I talked about just now. I think we are, as a team, we are definitely trying to, for example, opening multiple, laptops and trying to run it together. I think with data cleaning for several months or something, that's when we are trying to think of, if we have a data that spans over years. To estimate that. And the model we are currently using actually is probably one of the very efficient models, very efficient large language models that are currently available. So we've tried DeepSeek, but DeepSeek seems to be too big so that it runs slowly, or it returns many results. It was too wordy in terms of the results it returned. So it was sort of very slow also. So I think the current model we're trying is a model from Alibaba or yeah, something like that. So even with that, if we have years of data that we'll need to input, right? So the estimate is still several months. But do you mind if I contact you after the meeting? So I will bring the people who understand computer science in my team, and then to consult you about that, about how we can best improve the efficiency with that. Yes, thank you so much. Yeah.
Another question.
Yeah, I would say, thanks for your question first. It's a really good question. You're actually planning the project for me. What I will say is first, even if we're not planning anything, planning to compare it to anything, right? I think it will still be a valuable sort of piece of information, especially when it comes to policy, for example, or to understand human behaviors, basically in choosing whether they wanted parenthood or not. And also something else is if we look from a sociological perspective or the perspective of social sciences, we are able to probably understand, for example, a lot of the implications for that. For example, are people not satisfied with the cost of raising a kid? Or, is there more of a sentiment among young people who are actually using the internet towards, for example, gender issues in a society? Because we know in South Korea, a lot of women are not choosing to have a child simply because they are not happy about the gender equality situation in South Korea. So there will probably be a lot of sociological insights into, if we're worried about fertility rate, then what is the situation now, rather than, for example, seeing the fertility rates from dropping and trying out different policies to see if they're effective, right? And another thing is what you mentioned also make a lot of sense to compare with the current fertility trends and things like, provided if we're able to pass the data cleaning stage, right? So if the fertility trends has been, dropping, but the sentiment was actually okay. So, that has some other implications for how we understand this thing in a whole picture, right? Yeah. I think there's one more. That's actually a very good suggestion. We haven't looked at this. And also, the sample I select here is a small sample. So I actually I purposefully picked shorter ones for the time sake of the presentation. So there are actually some of the shorter ones that are actually super relevant, or some of the super long ones that are not relevant at all. For example, people are probably talking about some stories that are not relevant to their own opinions and things like that. So, but I think this is definitely a very good suggestion. We'll definitely think about it and try to see if that can sort of help improve the efficiency of the data.
If you have multiple set of features, then the chance of the irrelevant ones being reduced is increased, whereas the non-irrelevant ones, as in the ones that are relevant, has a higher chance to still stay within the clean data.
Okay, can you suggest a few features that we should?
I think one of the things definitely is the token length of the conversations. Then the other thing would be that maybe if there is like a large conversation, maybe the replies to that is also sort of relevant because it is still having the context of the conversation. Like if you say a Reddit, so if there's a lengthy conversation, then maybe a reply to that. It could be an opposing polarity as well.
Opposing polarity in terms of.
Like for example, if there's a positive polarity in terms of the childbearing sentiment, maybe since Reddit is usually a place where you have flame wars at times, so the replies to these comments might also indicate opposite polarity.
Okay. The length of the replies, right? Yeah, that we do have some sort of filter in terms of that. Yes, thank you so much. These are all very good suggestions, and we'll definitely consider that. Yeah, yes. Oh, really? Okay. Yeah, sure.
So he's an expert of information retrieval. You can.
Okay. Yeah.
Connect later.
Yes. Let's talk later after the talk and things. Yeah.
So next is Ray.
Okay. Thank you so much.
And
Oh.
so this is also at the crossroad between computer science and also social sciences. That's why Ray is speaking after me.
Thank you. Can I use my own laptop? Good afternoon. My name is Ray Mao. Currently, I'm a research scientist at NTU. I'm glad to introduce our latest research about metaphors. We found that metaphors are so helpful for understanding our cognition and emotional states. Speaking of cognitive analysis, researchers likely start from analyzing subconscious mind. This is because the subconscious mind governs 90% of our mental capacities like feelings, thoughts, beliefs, emotions, and so on. Another reason is conscious mind sometimes may not tell truth because it frequently involves logical thinking. People may hide their true intention by asking some unrelated questions or maintaining polite behavior to avoid revealing their actual thoughts. This video is an example of what association test showing how psychologists analyzes a subject's cognitive states from subconscious mind. This scene is from 007 Skyfall. The psychologist says a word. James Bond immediately replies the first word coming to his mind. He has no time for thinking twice. So the reply reflects his projection of the given concept in his subconscious mind. There is a very interesting concept of projection. The psychologist said heart, 007 says target. This is reasonable for him because he was trained for aiming at heart and then shooting. This is his job. But for normal people like me, it's not easy to build up such concept mapping because we did not experience shooting very often. So we may have a different concept of mapping, like heart is love, because the first image coming to my mind is the heart symbol, which represents love. On the other hand, we can see the limitation of this kind of the psychological task. It's interview-based, which is expensive, time-consuming, and difficult to generalize to big population. Thus, we choose another medium to analyze cognitive patterns and concept mappings, which is metaphors. First, metaphor also reflect our spatial mapping from one concept to another. When we say I spent 3 days to read a book, conceptually, I used a money concept to illustrate the time concept because I used the metaphor spent. In my mind, time is money, and this concept of mapping was built unconsciously. Second, we speak more metaphors than we think. Relevant statistics found that people speak 8 metaphors every minute. So metaphor allows us to obtain a large amount of concept mappings from everyday language. If you have a tool that can automatically parse metaphors and concept mappings, we can effectively analyze cognition for a big population at a low cost. After a few years of efforts, we have developed a tool called MetaPro for end-to-end metaphor identification, metaphor interpretation, and concept mapping generation. There are several novelties in MetaPro. To enhance multitask learning of metaphor identification and part-of-speech tagging, we developed a novel software parameter sharing mechanism enabling effective feature sharing between the two learning tasks. To address the challenge of the absence of annotated data for metaphor interpretation learning, we pre-train a language model and combine the pre-trained language model and WordNet to infer the most likely paraphrase of a metaphor appearing in a context. This work was done in 2018. Now, prompt-based in-context inference has been very much popular in the era of large language models. And then to address the challenge of the absence of annotated data for concept mapping generation, we proposed a dynamic rewarding mechanism enabling the model to learn the concept mapping generation task from the supervised signal of metaphor identification. So we have labels for metaphor identification, but we don't have labels for concept mapping generation. So even though we don't know the ground truth of concept mapping, we will reward the model for a successful concept mapping generation trial. The successful concept mapping generation trial means it results in more accurate metaphor identification. Thus, we can use the learning signals of metaphor identification to supervise the learning of concept mapping generation. Recently, we found that the conventional language modeling method, say predicting the missing word from a context or predicting the next word from the context, is suboptimal for metaphor processing tasks. Then we propose a novel language modeling method called anomalous language modeling. The idea is to identify a randomly replaced anomalous word in a context and retrieve the original word from a list of synonyms. This step simulates the tasks of metaphor identification and interpretation. Thus, anomalous language modeling is more effective than the conventional language modeling. Finally, we assemble the metaphor identification, interpretation, and concept mapping generation module, developing the MetaPro system. With MetaPro, we did a lot of cognitive analysis studies. first, we want to show that metaphors can result in different brain reactions compared to literals. We found that the activated and deactivated regions in our brain are different between metaphors and literals. Meanwhile, we also found that different concept mapping can also result in different brain activities. This observation justifies that we can use metaphor to study cognition because it's a reflection of our brain activity. Another rationale of using metaphor to study cognition is that there is a moderate correlation between metaphorical cognition and human decision making. We explore this connection in the context of UN Security Council debates by analyzing metaphorical cognition from the speaker's presentation. We then examine the correlation between the metaphorical cognition and the voting consistency between two countries in the UN General Assembly. Our finding reveals a moderate correlation between these variables, suggesting that metaphorical cognition can influence humans' decision making. This shows the potential of metaphor analysis in understanding how people shape their choices and behaviors. With the above empirical evidence, we did cognitive analysis from metaphorical language in a wide range of domains. For example, in this work, we compared concept mapping patterns between human and ChatGPT generated text and found that ChatGPT has its concept and concept mapping preferences. It is not the average of human concept mapping. This conclusion is supported by the distribution comparison. Well, on this part, we can see that for human, the activated concepts are evenly distributed in the concept space, but ChatGPT tends to activate more blue concepts at this corner. We need to be aware of this concept preference of ChatGPT because relying on ChatGPT generated content to train the future large language models could amplify and propagate the biased thinking framework. The frequent usage of large language models may also influence humans' thinking diversity. In mental health, we found that depressed people frequently have concept mapping like level is importance. In contrast, this concept mapping is not significant among normal people. Level is an objective concept used for quantifying rankings or intensities, but its metaphorical association with importance suggests that individuals with depression may subconsciously associate higher levels with greater significance, potentially amplifying the perceived failures or struggles. This cognitive pattern could contribute to the feelings of challenge or negative impacts because they may interpret those as as being more severe than they actually are. For some people, conducting psychological tests face-to-face is impossible. In such case, metaphor analysis offers a valuable alternative as it provides a non-invasive method for examining the cognitive patterns. For example, we analyzed the cognitive impact of the attempted assassination of Donald Trump we compared his metaphorical cognition before and after the 2024 gunshot incident to his concept mapping from 2016 during his first presidential campaign. We found that his post-gunshot concept mapping more closely resembled those from 2016 than those from just before the gunshot incident. This shows that the traumatic event may have triggered a psychological recession, temporarily reverting his cognitive pattern to an earlier stage. This finding highlights the potential of metaphorical analysis in understanding cognitive shifts following traumatic events. To sum up, metaphors are not just linguistic tools, they are windows into the mind. Supported by both brain signals and behavioral evidence, metaphors offer a unique lens for understanding humans' cognition. And then with MetaPro, an end-to-end system, we can pass concept mapping and explore explore the cognitive process in depth. Whether in technology, mental health, or politics, this approach opens a new door to understanding how we think, feel, and make decisions. Thank you. Okay, before answering this question, can I ask you a question? How do you think your language skill come from?
Of course, it comes from events and experiences.
Yes, so your language reflects your past experience. In other words, your language reflects your cognitive states given by the previous experience. So, yeah, I think even though we may have some common language, we may use some common metaphors, but the distinctive ones reflect your unique experience and cognition. Okay?
Also another thing, so if, apart from traumatic events, are there any other events, like probably things like some sort of surprising event that also probably triggers attention on these particular concepts?
Yeah, I think our cognition can impacted by a lot of events. Some events may be aggressive, some events may be soft, but because of these events and experience, you becomes you. Yeah, please.
I was like super fascinated about the idea of analyzing I'm thinking about we can use Singapore University, then again, I put the whole Prime Minister Macron's speech it's probably crafted not only by himself, but also by a lot of people around him. So we can do circumvent this kind of like getting multiple people involved and experimenting with metaphorical patterns.
Yeah, I think the advantage of analyzing human cognition from metaphor is we can distinguish people's cognitive patterns by different concept mapping. Besides, we can easily obtain concept mappings from a big population at a low cost. So if you're talking about is it possible to use metaphors to analyze group cognition or cognition for big population, I think it's possible. Well, Well, that's a good question. Actually, we had this question at another paper analyzing CEO's cognition. Yeah, some report may or document may be modified by someone else. It's not directly reflected the cognitive states of the person you want to study. But if you consider CEO as a figure of an organization, his speech, even though it's modified by someone else, but it represents the company or the basic some idea or thinkings of the company. So if you really aim at analyzing a person, then definitely you need to obtain the data from that person. But if you aim at analyzing an organization, then even though the document may be organized by someone else, but it still represents the idea or the thinking of the company. Yes. Yeah. Okay, yeah, so this work, our corpus is a question answering data set. So given the question, there are answers from both humans and the ChatGPT. So they are on the same page in terms of perceiving the external stimuli. And we analyze the concept mappings from human-generated text and from machine-generated text. And then we plot the concepts and the concept mappings on this space. So the left sphere represents the target concept. So in metaphorical expression, there are two concepts. One is target concept, which is the real meaning you want to say. Another concept is source concept, which is the concept you borrowed and use metaphors to illustrate the target concept. So this is the target concept, this is the source concept. And this is for ChatGPT. This is the target concept, this is the source concept. So for humans, we can see that the activated dots, the blue dots, the yellow dots, and the green dots on the top, they're evenly distributed over the concept space. So it reflects that the human thinking is more diverse. But for ChatGPT, most of activated dots are concentrated on the corner, the blue dots. Because you see that you cannot see much green dots on the top, you cannot see much yellow dots here. So it shows that ChatGPT has his concept preference. So in other words, if we compare ChatGPT as a human, he has his own thinking, or he has his own thinking framework and the concept selection preferences. Yes. Yes, we do not plot the entities. We abstract a concept from entities and plot this. Okay, thanks. Thank you. Ooh, sorry. Sorry.
Good afternoon, everyone. My name is Diksha, and I'm a postdoctoral candidate under Prof. Gian Marco from NUS. So today I'll present an information extraction system, which basically tries to predict vulnerabilities and impacts related to extreme weather events. So extreme weather events such as California floods, San Diego floods, etc. So here our approach basically leverages AI and NLP techniques for analyzing news articles, trying to identify specific, you can say, vulnerabilities, what are the key indicators of vulnerabilities, and trying to assess the consequences of extreme events. So this system basically aims to support decision making for disaster prevention. So we start by first web scraping news articles from Google News. So here we use the names, dates, and locations associated with extreme events, which are listed on several websites like Climameter, EM Data. We have actually curated more than 1 million news articles from 30 days before and after the event actually occurred. So once we have the data, what we do is we do the GPE tagging. So basically we annotate or we tag the news articles with the different types of locations which it mentions. Now, using this tagged data, what we do is we try to build a deep learning framework where we try to classify sentences based on whether it denotes impact sentence, like, okay, there is an example like, meanwhile, at least 9 people have died in the western state of Najafgarh due to suspected heat stroke, or it's a sentence which is somewhat denoting vulnerability at a specific location. So, yeah. So after extracting such kind of information, the information is further filtered based on to basically get more accurate information related to the extreme event. So, so basically for an extreme event, we have specific locations where the event could have occurred. And what we do is we tag these locations with geocoordinates, and based on the area which it covers, we try to filter out irrelevant sentences or irrelevant information from our data. So, like if if the extreme event is like India heat wave, then we don't want articles mentioning Shenzhen as a location. So once we have this kind of data, we try to get more structured information from this data, such as we try to build a knowledge graph. So what we do is we first start by building a taxonomy of different topics such as impacts, vulnerabilities, or you can say emergency responses, and under that we try to extract concepts using different NLP techniques like dependency parsers and concepts like loss of life, deaths, and so on. Now, in addition to that, we also have a detailed module which contributes to emotion and sentiment analysis. Here we are trying to use different deep learning frameworks, and for example, in this case, for these 3 events, Typhoon Yagi, India heatwave, and China floods, we try to analyze the different kind of emotions which are prevalent during that extreme event. So majorly you can say during the event the emotions fear and anger were prevalent, and like as the event happens, sadness is also a very large, an emotion with large effect. So yeah, so simultaneously we also have sentiment analysis. Then after this, to evaluate basically the whole information system, we have 2 types of evaluation. Like one, we have the quantitative evaluation, where we are basically trying to evaluate the system based on different metrics like number of deaths which happened, number of injured, the number of affected population, etc. So you can see from our information extraction system, we are trying to get, we got like for the event Typhoon Yagi, we got deaths as 290, which is comparable when compared with the information reported in EM data. After that, for qualitatively analyzing different events or our information extraction system, what we do is basically using the knowledge graph or the concept mapping. What we do is we try to we try to map different locations with the different kinds of impact and vulnerabilities it tries to have. So you can see for, say for Typhoon Yagi in Vietnam, there was a lot infrastructure damage done. But what our system also provides is like our system can basically pinpoint to more granular locations in Vietnam where different kinds of vulnerabilities or impacts have happened. Like in Hanoi, infrastructure damage was there, death was there. Phu Tho also same kind of impact. Then there was, because of strong winds, there were some vulnerable areas in Hanoi and so on. So yeah, so this is like an ongoing work which I'm currently doing. So here our like the next steps is basically we are going to build our own large language model which will be able to handle all the previous tasks which we have just discussed. And it's going to be a very domain specific model which will basically adhere to all the tasks related to extreme events. So thank you. If you have any questions. Yes, 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 yes.
I was wondering, were you also considering using some sort of a retrieval augmented generation where you put the knowledge that you've
Yeah.
gotten from
Yeah.
these events into some sort of a vector store or knowledge graph and then just go and do it?
Yeah. So instead of relying on RAG methods, because those systems, yes, they can change according to the knowledge base and everything. What we are trying to first build is a comprehensive model which can basically handle tasks like, for example, you saw our first task was trying to classify sentences based on vulnerabilities and impacts. So that particular model will be capable of for example, it's given an instruction or it's given a question. Okay, this is a sentence. Tell me whether it's a vulnerability sentence or impact or anything else. So it will be capable of answering those questions first. And then yes, an RAG can be obviously incorporated at the end for newer info, like to gather newer articles or newer events to cater those things. But yes, first we want to have a specific model which for which we are going to utilize the data which we have curated till now for more than 60 extreme events we have. So yes, because one more reason is that we have a lot of other tasks, like this is one of the tasks. The other task is basically to have such kind of keyword extraction from the data itself. Then there is another task of summarizing the, you can say, the vulnerabilities or the impacts happened at a particular location. Because right now what our strong point is, we have location specific information from our data. So that we want to first have, like you can say, those all properties we want to have in our LLM. And then obviously, because our RAG is mostly like fine tuning on a particular, you can say, large language model. But here our goal is first to build our own language model, and then more fine tuning tasks can be easily achieved based on the new data which comes.
Just a follow-up on so like when you're considering building the language model, are you looking at building it from scratch as in,
Yeah.
or are you looking at distilling from another large language model?
Yeah, so we are doing, yes, pre-training has its own cost, as we all know. So probably we are going to first start with distilling the knowledge from large teacher models, more than 70 billion parameter-based models we'll be trying to use, and then trying to have it in a very small model, 1 billion, 3 billion, less than that. So that, because we want, ultimately we want it to be, you can say, you can say personalized framework, like website or software also. We want that. So if we have lesser, like you can say, memory models, it will be easier to deploy them for for applications. Yeah, that's our goal. Thank you. Okay, thank you.
Only 10 minutes left for
Oh, sorry.
just gonna skim through these slides. Anyway, there is a YouTube video on this very same talk, so you can watch that later if you are interested. There are here also some interesting links to those that, for example, want to join us as an intern, or even we're hiring now as CCDS, if any of you from outside is interested in that. And we're looking at many different things. This short paper can also be interesting for some of you who wants to, maybe not from computer science, who are wondering how to adopt AI. So in this short paper, I discuss the steps that are required to, for example, starting from interpretability. If you're building your AI from scratch, how to build explainability on top of interpretability rather than having generated explanation. And then beyond that is also important to evaluate these explanations. We do it for sentiment analysis in terms of utility, robustness, and faithfulness. Another interesting paper that we published recently is the plagiarism singularity conjecture. So it takes from the infinite monkeys paradigm, where the question there is how long does it take for a monkey to randomly type to be or not to be, or something like that. And so now if we replace the monkeys with LLMs, how long is it going to take before LLMs have already covered all the possible human writing? So after that, supposedly everything will be plagiarized. So this is actually, this is a funny short paper, but it's also an important question, even for us teachers, how to make sure that whatever content we produce with large language models is not plagiarized in not just from a syntactic point of view, but also semantic point of view. Personally, I'm also interested in talking to people from social sciences to understand also, for example, the impact of AI on human intelligence. So for example, is it a good idea to let young kids use large language models? Can it hamper their written or spoken production? So here in the slides you have some pointers to also what is the role of AI and humanity. Like some people say that the main goal of humanity is really just to produce this AI that then will live on after maybe humanity no longer exists. So these are also the kinds of discussions that I would like to have with you guys, maybe during lunch, since there's only a few minutes left. So there's also philosophical questions, whether we are a good model if we're working on affective computing, how much of the spectrum of the emotions we want to emulate into machines. So with all this in mind, we came up with the idea of the 7 pillars. This is another short paper that you can look at, and it's for us, it's a sort of roadmap, but also call for collaborations to decide what to be focusing on in the next few years. So again, I'm just going to skip through these. But then, yeah, something interesting that we are working on, and this is the latest version of CentiGNet, CentiGNet 8, which, as I said, is freely available on our websites. Also, we're looking at how to mitigate the symbol grounding problem. So we're trying to find out a way to emulate meaning in terms of some sort of universal symbolism that can handle all the nuances and richness of natural language, and with a representation like this that just tries to emulate how in our mind we conceptualize the concept of buying something, buying a phone in this case, whether this is also equivalent for different cultures, different minds, different languages. And so all this goes under the umbrella of neurosymbolic AI. So in our group, we use a lot of large language models and statistical models, but together with knowledge graph and semantic networks. And this is also very much cognitive inspired because also we humans don't learn everything by example. We also learn a lot of things in a top-down manner. So I'm talking, for example, about common sense, knowledge, representation, and reasoning. So many of these topics, as I said earlier, are summarized in this textbook. And once again, if any of you is interested in collaborating with us, these are the research umbrellas that we are working on. So in the slides, you have some examples like the work of Shulang and many other works, one example for each umbrella, and also some projects. Some of our students are also working on these implementations. Food is ready, so I don't want to keep you too long. In the last few slides, I also put again the same call for papers from before. This is open call for papers. There's no deadline for this. You can send your papers anytime. This is Cognitive Computation Journal, so it's multidisciplinary. Even people not from computer science can send here. There's this book series and some special issues coming up. And here, finally, the resources that I mentioned before with some more links in the slides. So thanks for coming. See you at next S3A in 2 years, hopefully somewhere else. So I'm open to suggestions. Maybe next time we can do it at SMU. We always say this, and then we always end up here at NTU. But anyway, if you also have, once again, the slides are here. And if you have any suggestions, please feel free to tell us. And let's have lunch. If you want to ask me some questions, maybe you can ask during lunch. Or is there anybody who wants to have some more final remarks or even question? Yeah, we have another 3 minutes. Yes? Yeah, so we use a set of primitives that we were developing from CentiNet 7. So it's an approach that is both bottom-up and top-down. So we have those sets of primitives that are mostly positive versus negative primitives, but also we take a bottom-up approach by using some reviews from training data sets that we have to cluster all the words and multi-word expressions that supposedly mean the same thing on top of having the same polarity, and then we try to meet in the middle. Okay, that's all. Thanks for coming, and I think there's some food outside, right? So yeah, please enjoy, and if you have, please talk to each other. So I hope the main goal of this is to foster collaboration between different schools, different universities. So please talk to each other during lunch.